Hello, everyone. Can you hear me? People at the back? Yes, thank you very much for your feedback. So the talk will be about the practical guides to the database logs, especially with Django Web Framework. Let me introduce myself beforehand. I've been working professionally for 7 years. My current role is like a tech lead and senior backend developer. I mostly build APIs, infrastructures, and services. For last couple of years, I mostly focused on decentralized blockchain applications. But some people say me just Django developer. So I also organized PyCon Turkey and PyIstanbul. And we also organized one of the PyCon in Turkey. I see that it's really hard to organize a PyCon in new country, so I would really like to thank the PyCon Portugal organizers for having this event. Also, I have a well-maintained blog under fa.me. You can also reach out the slides after my talk from here. So let me start with the table of contents. So it will be around 30 minutes, and hopefully we will have a Q&A at the end. Take your questions. My main experiences with the PostgreSQL. So most of the related content will be also the PostgreSQL. So I'm not sure about will it be same for the other databases like MySQL or Oracle DB, but I would like to give you some perspective about the logs. So I think that it will fit most of the databases. And the examples will be on the Django Web Framework, but thanks to Django simplicity, most of the frameworks are really easier to exchange between each other. So if you are a Fast API or Flask developer, don't be shy. They will be related to you. So let's start with the why question instead of how question. So why do we need actual logs? Do you have any ideas about it? For sure, it should be maybe you can ask it. Yeah, for the safety of the safety of the program or system. So actually, I have an example in here, a funny example. So we are in Portugal and we really enjoy pastel de nata, and we ordered a plate of the pastel de nata for the share. But we get some bites at the end. We only have the last piece, but actually all of us would like to have this. But actually, who would like to have, or who is going to have the last piece? Actually, all of us. So actually, it is called a concurrency problem. Also, we have this problem in modern web applications. So actually, the logs try to prevent this type of concurrency problems and try to have this not only for one person at a time. So then let's dive more technical side with another example or challenge. We need to make a platform for selling event tickets, for example. Basically, it will be similar to Ticketmaster or Songkick. We will just selling tickets for many events. There are a lot of events ongoing in the world. In according to your preference, you can list events, search events, and you can get the tickets for these related events. Imagine that also PyCon Portugal or Dua Lipa concert as a event in this platform. So, as most of the modern web applications, it's also an online platform. So there will be multiple users at the same time who would like to use same application. So if you start with a naive method, we will have two models. The first one will be an event model, which only have two fields. The first one is name, basic information, and we also have a capacity left field as an integer field. I didn't would like to have a bunch of fields to keep it simple. So as I mentioned before, as an event ticket seller, we have a constraint. Events are for limited people. So each venue has a limitation. So we use capacity left field for it. Then we have a ticket model. It has a relation to user. In the user, we have a name, like personal information, like IDs, telephone numbers. And also we have a secondly ticket as a foreign key to the event model. So there can be a multiple tickets in an event, and at the same time a user can have multiple number of tickets, basically. So we should be a good developer and put the creation logic inside of a specific method and not call the directly ticket object create in the where we use this creation logic. So let's take a look at this. We fetch the event object at the line of 6. Then we check the capacity. If the capacity is 0, then we just raise an exception that will say that there is no capacity left. Then we already did our check. We need to create our ticket. Then we reduce the capacity by 1. Then we send an invoice to basically the user. Looks good, right? But on a sunny day, maybe Sunday or late Friday, you will get a report from the user, not from actually a Sentry, even Sentry. It's the worst type of reporting. Then you get an issue from the user. And it says that for PyCon Portugal, we already have 201 tickets, but actually our capacity was 200. So how actually it happened? So let's take a closer look to the creation logic. And I would like to point to line 8 for this slide. As you can see, we check the capacity left and we create the ticket after it. So when we're reading the code from top to bottom, it seems like it should be working right. But actually, in our modern applications, we have multiple processes at the same time. So actually, multiple processes can reach these lines at the same time, and we might have a race condition in here. So let's dive in this. But before this, I would like to mention a principle or term, which is a time of check to time of use. Time of check to time of use is a race condition that occurs when a resource is checked for a particular value. That value then changes before the resource is used or resource checked. This race condition is really common, by the way. In March 2023, like 6 months ago, a cybersecurity team found out that this problem in the Tesla Model 3, and they awarded it at $100,000. So it might happen to you too. So on a sunny day, actually, Mari and Pedro would like to buy a ticket from PyCon Portugal for themselves. But there was only one seat left at that time. As I said earlier, we have multiple processes and app servers. And we start with the process, like process 1. It checks the capacity, is it 0 or not? If it's not, okay, then the process is going to continue. Then at the same time, we have another process, which is process 2. It checks the same thing, but for Pedro, not for the Mario. Then we don't have, we cannot be sure that process 1 will always be quicker than the process 2. So this type of processes can be slow because of they might be in different machines. Operating system can be prioritized different things at the same time. So at that time, process 2 can create tickets for Maria beforehand. But on the process 1 side, we already did the check for the Pedro, and it was okay. So we actually created another ticket for Pedro too. Then it became the race condition for us. We created an extra ticket for event, but we don't have actually enough seats for our event. So what should we do? As the name of the, as we can understand from the name of the presentation, we can lock the table as a brutal solution. So what did I change? In the line of sticks, you can see that I have a context processor, which is transaction atomic. And you need to have a cursor object of transaction for having the lock the table. And in here, we will get details of it. No need to confuse about the naming of the logs, but we will actually have exclusive log in here. What does it actually mean? What does it actually do? So when this happens, no one can actually read anything from the ticket table. So if we run same process at the same, different process at the same time, one of them should be working at a time, other one should be waiting for the others. But as you can see, it's a bit slows down our application. Because we have multiple events in our system. For example, we have Dua Lipa concert. There is a, for example, there is a really high demand at currently people would like to buy it, but actually buying Dua Lipa concert ticket will affect on the readings of PyCon Portugal too. So actually we really have a system which cannot scale on the long term. So what can we do as a improvement? Basically, we can just lock the related PyCon Portugal row for this. So in Django, there is a native support for select for update. In the line of 7, you can see that we when we create a query set, we just say select for update and get the event ID. And basically, you did a pessimist locking and you learned something new. It's called pessimist locking. Actually, there are 2 types of locking strategies. The first one is optimist locking, and the second one is pessimist locking. As I said to you before, you learned pessimist locking. So what's pessimist locking strategy actually? As soon as one of the users starts to update a record, a lock is placed on it. Actually, this is the really pessimist approach, maybe. On the other hand, we have another strategy, which is optimist strategy. To be honest, I'm not a big fan of this strategy because I'm a lazy developer, but we need to have a version field in each table when you like to have a optimist locking system. So how does it work? Actually, you need to pass the version when you update the object. And as you can see on the line 14, you just update the related version. But if there isn't a version or another process updated this version only, this update statement won't update any rows actually. So it needs to introduce any version field. So as you can see, there is a lot of repetition in this. And Python suggests us contribute yourself. So basically, there are already packages for it. You just need to install them for a project and add these mixins to your model. And basically, that's it for having successful concurrent writes for your applications. But as Steve Jobs say, there is actually one more thing. Actually, this is really important for you. These are actually the forgotten logs. So we learned how we create log, how can we use, why do we need it? So it's time to have a quiz, maybe. In here, we really have a simple SQL query. And what do you think about this query? is this query gonna create a log during the execution of this query? Any guesses? Who says no? Who says yes? Okay. Actually, it will create a log during this execution. When I see this, I really shocked because it just selects from a table, just reads, don't write anything. So why this should be creating a log? So I'm going to deep dive in details of it. Also, we have another thing. So we can also insert data to our database, like this SQL command. What do you think about it? Will it create a log? Who says creates log? Who says no? Okay. Actually, this is also going to create log. So as you can understand that in the first part of the slide, I mentioned the logs that we create as a programmer or backend developer. So these are for having our database more consistent in our application perspective. But actually, PostgreSQL creates same thing for their own consistency, because PostgreSQL can support multiple processes at the same time. So they need some kind of locking mechanism at the background of it. So this is my favorite web page up to now. I read this web page almost 100 times, and I didn't get anything. Maybe if you like to torture yourself, you can read this documentation when you get bored. It's really hard to understand, actually. But I think it's a bit because of the design of the documentation, not the feature. Basically, we have 4 types of logs, table level logs, which we already did in the first implementation. Then we have a row level logs, and we have a page level logs, which even PostgreSQL or DBAs don't know anything about it. And we have advisory logs. So databases also need log for themselves, not only for us. So we have a 2 perspective actually about logs. So let me introduce table level logs for you. We have access share, row share. This is actually a table level log, but there is a row naming inside of it. I don't know why. Row exclusive, share update exclusive, share row exclusive. So we have exclusive rows, shares. I think they are not seems very intuitive to understand, right? Also, there is a giant conflict table of logs. So when I see that, I don't actually understand anything. But I try to create an analogy from it, which is basically, I try to think like logs, instead of their names, I would like to have a color for them. Like, for example, when you have an access exclusive log, it's like a really red thing. So you cannot conflict with this log with any operation, even select operation. So in our first example, actually, we used access exclusive log, then it's log all the things. So also we have row level logs, which also don't make any sense, but thanks to open source and thanks to Hüseyin Nasser, he created a documentation by own. People also do this type of thing. Not only packages, they can also do documentation for other people. So actually, I don't really care about the conflicts of logs as a developer. I'm just interested in the conflicts of SQL commands. For example, when I insert something, should I block my selects, or if I create a new index for having quicker responses, will it affect my selects at the creation of the index? So thanks to Hüseyin Nasser, it's by the way, quite new project, almost 3 weeks old. You can see for example, when you have a select operation, what will happen? Which operations are blocked? So also I would like to mention about the downtimes on deployment with migration. Who had downtimes while having a migration or deployment? I think every backend developer should have in their CV this type of thing. Funny or happy accidents. So if you try to reduce this or not having downtimes in your future deployments, I think this is the part which you are interested in here. So most of the time when you open the homepage of your application, for example, this event application, you see the list of events, featured events, these type of things. And most of them are actually read operations like select queries. Actually, in this pglogs.org documentation, you can see the conflicting commands, SQL commands with the select operation. So as you can see, when I, for example, reindex something in the DB, all of the select operations are blocked. So if I alter table or drop table itself, or truncate and delete all the data, so all the select operations will be blocked by this other command. So, for example, you have a new index added, or you rename your table, and during the deployment, also if it's a giant table like with millions of rows, it would also take time for the database to complete this. And during that SQL query to run, your users will try to open your web page or web application. The application itself will execute the queries, but they won't get any response from the database. So also there are other things to do. But also we have another alternative SQL commands for the not conflict with the select command, which is reindex concurrently, create index concurrently. So actually in PostgreSQL, you can do these type of things concurrently. What does it mean? Actually, you start doing, for example, creating a new index, but it doesn't need to be ended at the draft time. It triggers the process. You can finish your migration. You can start having new users, but on the backside of the PostgreSQL, it will create the index tree by your own. So if you not like to have a downtime on your deployments, you need to use this type of concurrent operations instead of blocking operations. So Django already supports this in the migration operations. So you can use add index concurrently or remove index concurrently. Basically, you can add the index in your model, call make migrations. It will create a migration file. You just need to change add index to the add index concurrently in the migration file. Also, you need to do something else. DDL, a data definition language, which is a transactions which contains create, drop, alter, or truncate, don't support atomic. So when we have a migration, if we have an atomic enabled, it will fail. So you need to set atomic to false in these migration files if they have a concurrency. Then you need to add index first as a concurrently. Then you have another deployment to do, which do this index-related application checks applied. So I also have another warnings for you. Don't create not null column in a deployment for a large table at once. So you need to create as a null, fill it after your deployment. Then you can change it afterward. then don't create a column with default value because database would like to fill all of them at once, but it's a problem for you. And I hope that you won't have any downtimes on your deployments. Obrigado. That's all from me.